Welcome back to Iron Process, where the world's most extreme industrial operations and largest engineering systems come to life. Today, we enter the world of maritime engineering, where colossal ships are built, silent machines operate beneath the sea, and high-stakes missions unfold across the open ocean. From construction and repair to offshore infrastructure, salvage, and decommissioning, each process reveals how humanity continues to expand its reach across the water. Let's begin. This footage captures the full berth and float-out process of the mega cruise ship Spectrum of the Seas, owned by Royal Caribbean Group. The vessel was built at Meyer Werft, one of the world's most respected and historic shipyards in Papenburg, Germany. Inside this vast building hall, the scene feels almost unreal, like a giant industrial puzzle being assembled piece by piece. Meyer Werft's indoor dock gives the yard a major advantage. Construction can continue day and night, regardless of weather, helping teams meet demanding deadlines. One of the most important mechanical stages is the installation of the Azipod propulsion system. Unlike traditional rudders, these units can rotate 360 degrees, producing strong thrust and exceptional maneuverability. That allows an enormous steel structure to move through narrow channels with surprising control. At the same time, while hull work continues, thousands of workers move into the outfitting and systems installation stage. Little by little, the ship changes from a bare mechanical structure into a floating five-star resort. On the exterior, the name Spectrum of the Seas is painted in place with pride. But not every engineering achievement is visible on the surface. Some of the most advanced machines in the maritime world are designed to remain unseen. The S-81 Isaac Peral submarine is a clear example of hidden power beneath the sea. On the 22nd of April 2021, in Cartagena, the vessel was officially launched, marking the result of years of research and development. At roughly 70 meters in length and nearly 3,000 tons in displacement, the S-81 is not massive in size, but it carries highly advanced technology. Most important is its AIP system, allowing it to remain submerged for long periods without surfacing. Inside its reinforced steel hull lies an advanced network of sonar, radar, and communication systems. Integrated with torpedoes and missiles, all of it is operated by a crew of just 32, working in a sealed, high-pressure environment, where even a small mistake can bring serious consequences. After launch, the S-81 entered a demanding testing phase, with every system evaluated before it could join the fleet. This is the final step that turns a technical achievement into a fully operational strategic asset. The S-81 is more than a submarine. It represents the ability to master highly complex technology. If the S-81 represents hidden power in deep water, then the Bay of Cadiz represents something different, a place where giants are repaired and renewed. Navantia operates 6 shipyards along the Spanish coast, but Cadiz holds a special role. Through deep expertise, the yard has become a strategic partner for major cruise operators such as Royal Caribbean. Its strongest advantage is location. Positioned beside the Strait of Gibraltar, it allows vessels to enter for repairs without making major deviations from their commercial routes. Inside the facility is a huge industrial complex centered around a 386-meter dry dock, capable of receiving ships of up to 440,000 tons. Around it stands a large system of cranes, warehouses, workshops, and heavy support infrastructure. But scale is only part of the story. What sets Navantia apart is how the yard operates as a complete system. Every day, it must process 500 tons of wastewater, while also pumping thousands of cubic meters of high-pressure seawater to cool engines and run air conditioning systems for ships sitting dry on land. Below the hull, workers remove propellers, inspect stabilizers, and use hydroblasting systems to strip away marine growth before new eco-friendly coatings are applied. Above, scrubber filtration systems are fitted into funnels, while interior teams refurbish cabins and entertainment spaces. These operations continue 24 hours a day, 365 days a year. For commercial vessels, time in dock is extremely valuable, and Navantia understands that every hour matters. Modern shipbuilding, however, is no longer only about welding giant steel sections together. At Meyer Turku in Finland, the installation of the aquadome represents another level of maritime engineering. Instead of building the structure piece by piece at height, engineers assemble the entire dome at ground level first. This method reduces construction time, improves safety, and allows critical components to be completed earlier. The aquadome does more than change the ship's appearance. It shows that the limits of maritime engineering are still being pushed further. The Norwegian Joy is one of the largest cruise ships in the world, but its path to completion was far from smooth. Built at Meyer Werft in Germany, the ship stretches more than 320 meters in length and carries thousands of passengers, becoming a floating city at sea. Construction began in 2014, with costs reaching hundreds of millions of euros. From the start, the ship was built through modular construction, with dozens of giant steel blocks fabricated separately and then joined with extreme precision. But projects on this scale always face risk. During construction, 2 small fires broke out, causing damage and forcing teams to react quickly. Though limited, the incidents were a reminder that behind every giant project lies a constant chain of technical dangers. Once complete, Norwegian Joy entered sea trials in the North Sea, where its engines, navigation systems, and hull stability were tested under real-world conditions before delivery in 2017. What makes Norwegian Joy striking is the contrast within it. On the outside, it is a space of luxury, with a 2-level go-kart track, restaurants, and entertainment zones. But inside is a dense engineering system that must run continuously with exact precision. One side is the passenger experience. The other is machinery. Both must function perfectly at the same time. Norwegian Joy is more than a cruise ship. It proves that the largest engineering achievements are always built from the smallest details. Building a nuclear-powered supercarrier stands at the peak of American defense engineering. The process begins inside a vast dry dock, where massive supermodules forming the keel and lower hull are lowered into place one by one. The constant shift between day and night reveals the scale of the work, stretching across years of continuous construction. Slowly, the carrier rises. Bulkheads take shape, internal sections are enclosed, and critical compartments, including the nuclear reactor spaces and aircraft hangars, are sealed within the growing structure. Then comes one of the most iconic moments in carrier construction. A giant crane lifts the island structure, weighing more than 500 tons, and places it onto the flight deck. On Ford-class carriers, the island is smaller and positioned farther aft, increasing deck space for aircraft operations. Once the steel hull is complete, millions of gallons of water flood the dry dock and the ship begins to float. It marks the end of structural construction, but only the beginning of a service life expected to last 50 years. The USS Gerald R. Ford is far more than a 100,000-ton ship. It is a mobile military base, a concentration of technological and mechanical power, and a strategic tool on the global stage. At the Foss shipyard, the construction of the Nicole Foss shows a different kind of engineering strength. This vessel is a lesson in durability, load calculation, and heavy lift logistics. Designed for the severe conditions of Arctic waters, it required specialized reinforcement throughout its steel hull and framing systems. The ship was built through strict modular construction. Bow and stern sections were welded upside down to improve access for workers and ensure the highest weld quality. Rotating these massive multi-ton sections required perfect coordination from heavy-duty cranes. Those logistical demands became even more visible during launch. The hull had to be carried by self-propelled modular transporters onto a floating dry dock. It was then towed along the river until it reached water deep enough for the dock to be submerged safely. The vessel's specialization becomes clearer during final equipment installation. Main engine units and ultra-heavy-duty towing winch systems were installed by floating cranes after the ship was already afloat. Only then was the pilot house added as the final major section. The Nicole Foss was never built for speed or elegance. It was built as a pure industrial machine, a powerful working vessel meant for relentless service in ice and some of the harshest maritime environments in the world. Far below the surface, another engineering system operates almost unseen, yet remains vital to the global economy. Offshore pipelines carry oil and gas across distances of hundreds of kilometers. They work in silence, but their role is essential. The process begins with seabed surveys. Using sonar and geophysical technology, engineers identify the safest route across the ocean floor. Pipe segments are then manufactured, treated with anti-corrosion coatings, and transported offshore. At the installation site, different methods are used depending on depth and seabed conditions, including S-lay, J-lay, and reel lay. As the line is deployed, each segment is welded and inspected continuously, while tension is carefully controlled to prevent damage or deformation. Once the pipeline is installed, it undergoes pressure testing and internal cleaning. In many cases, it is then buried for protection against harsh environmental forces. Every stage is designed to keep the system operating reliably for years. What makes offshore pipelines remarkable is their contradiction. They are giant engineering systems that affect entire economies, yet they exist almost completely out of sight on the ocean floor. This is another form of conquest, quiet, resilient, and essential. These pipelines are not just industrial projects. They are proof that human engineering can extend into the deepest and most difficult environments. The maritime world, however, is not defined only by construction. It is also shaped by rescue operations that demand precision, courage, and technical control under extreme pressure. The case of the cargo ship Modern Express in 2016 is a powerful example. On the 26th of January 2016, the 164-meter roll-off vessel was caught in a severe storm in the Bay of Biscay. it lost stability and developed a heavy list. All 22 crew members were evacuated, leaving behind a drifting steel mass at risk of capsizing and causing a major oil spill. As the vessel drifted toward the French coast, the urgent task was clear: secure a towing line and bring it to safety. On January 29, a helicopter placed 4 specialists onto the dangerously tilted deck, but strong winds and heavy seas forced them to abandon the attempt. By February 1, with the ship only 25 nautical miles from shore, the rescue team made one final effort. A second helicopter insertion was carried out. This time, through precise coordination and remarkable courage, the team secured a tow line to the tug Centaurus. With international cooperation and approval from the port of Bilbao in Spain, the vessel was safely towed ashore. But the operation was not over. The ship still had to be righted. Because it had remained in a severe listing condition, engineers carried out a careful ballasting and deballasting process. High-capacity pumps and generators were used to move water into and out of ballast tanks, according to detailed engineering plans. After 3 weeks of controlled work, the vessel was restored to a stable upright position and returned to its owner. It became one of the most remarkable rescue operations of its kind. The offshore energy industry faces another challenge when structures reach the end of their life or are damaged by powerful storms. Removing multi-ton offshore oil rig jackets in rough sea conditions is a major technical and environmental problem. For that task, the Versabar VB1000 heavy lift vessel was developed as a direct solution. With lifting capacity of up to 7,500 tons, the VB1000 uses a unique design. 2 parallel barges are connected by a massive arched space frame structure, turning the vessel into a giant mechanical pincer on the sea. Instead of sending divers down to cut structures into smaller underwater sections, a process that is dangerous, expensive, and carries environmental risks, the VB1000 uses single-lift removal technology. The vessel moves directly toward its target, positions its twin hulls around the platform, and lifts the entire twisted steel structure in a single controlled cycle. A transport barge is then moved underneath to receive the load. This aggressive but precise method reduces seafloor clearing from months to days. Lifting structures in one piece does more than save time. It reduces danger for salvage teams and offers one of the best methods for preventing leaks and environmental damage. Looking back across the entire journey, from giant cruise ships and silent submarines to colossal aircraft carriers, from invisible offshore pipelines to high-risk salvage operations, everything comes together into one larger picture. It is the image of humanity's ambition to conquer the sea. This has never been a simple journey. Every vessel launched is not only the result of millions of labor hours, but also the product of science, engineering, and knowledge built over generations. And in every rescue mission, the human element remains just as important. Courage, responsibility, and the ability to make decisions under pressure still determine the final outcome. A striking contrast runs through the maritime world. Some structures are built for luxury, while others operate silently in the shadows. Some projects serve commercial goals, while others stand as symbols of national power. Some are designed to last for decades, while others must be dismantled to restore environmental balance. Yet whatever their form or purpose, they all move toward the same outcome, expanding the boundaries of human reach across the ocean. The sea remains one of the harshest and least controllable environments on Earth, and yet it has become a place where humanity does more than simply survive. It has become a place where we build, operate, protect, recover, and expand. From transportation and resource extraction to defense and environmental restoration, every step forward marks another advance in technological capability and organizational strength. Perhaps most remarkable is that many of these achievements are not fully visible on the surface. Much of their value lies behind the scenes, in technical designs, in every weld, in every system that runs without rest, and in the people standing behind the work. In the end, the conquest of the ocean is not only a story of machines and structures, it is also the story of humanity itself, a species that never stops exploring, never stops pushing limits, and never stops turning the impossible into reality. As we look across the vast sea, one truth becomes clear. What has already been achieved is only the beginning of even greater journeys ahead. Thank you for watching to the end. If you enjoy stories like this, please like, share, and subscribe so you do not miss the next episode from Iron Process.